Okay, this is another problem from section 10.3. This is number 57. We want to find the area at 57. We want to sketch the polar curves, r equals 3 cosine of theta and r equals 1 plus the cosine of theta, and find the area inside the circle and outside the cardioid. So here's my circle, r equals 3 cosine of theta, and this is, okay, r equals 1 plus the cosine of theta. And you can see this over here. This is the cardioid, and we want the area. Okay, we're looking for the area that is inside the circle and outside the cardioid. The area that's inside the circle, but outside the cardioid. Now, here's the circle over here. Here's the cardioid. Now, this is all part of the cardioid over here, so we want this red area. Now, we can see where they intersect. Now, if you check where they intersect, if you set the curves equal to each other, 3 cosine of theta equals 1 plus the cosine of theta, you could subtract cosine, so you have 2 cosine of theta equals 1, so cosine of theta equals 1/2. And that's going to be either pi over 3 or negative pi over 3. So in this case, it's going to be here or down here. Down here, the way they intersect, this would be the negative pi over 3. And this is a pi over 3, so we can use symmetry. And we can just get this area here, this red area, and then we'll just match it. We'll double it, and we'll get that red area also, and that's what we're looking for. This red area and this area down here, which should be red, but just for right now, we won't mark it, but this was all the area we're looking for. The area that's inside the circle, but outside the cardioid, and the cardioid covers all this, so it kind of blocks that off. Now, what we can do is we can take the area of the circle, okay, from 0 to pi over 3, so that's going to be all this. Now look at this line, pi over 3. There's a little part of the circle that's out, but it's also part of the cardioid that's out. So we're just going to take it up to there. So you have to kind of be aware of how this work looks, because if you aren't, sometimes it's going to be a little misleading. So we're just going to take the area from 0 to pi over 3, and I think that makes it a little bit easier to see that. So there you could say, well, there's a little wedge of the circle, but that's also part of the cardioid, so that's all going to be canceled out because we don't need that, because we just want this little wedge over here. So we're going to take the area of the circle from 0 to pi over 3, that's this whole part over here, that's the red and the green, and we're going to subtract the green, which is the area of the cardioid from 0 to pi over 3. And then that's going to give me the red area. So this whole red and green, which is this, all right, minus the green gives me the red, and that's what I want, but that's just half of what I want because I also want this part down here, so I'll times 2. So that's your setup. And that's the hardest part. Once you have that, the rest is all mechanics. Okay? So we're going to go from 0 to pi over 3 of 1/2 3 cosine squared, so this is going to be 1/2 r squared d theta. That's our area formula. Hopefully you got that down pretty good. And I can square this, so 3 squared is 9, and then I can bring out the 9 in halves, and I've got cosine squared, and I'm going to use this technique over here. Cosine squared equals 1 plus the cosine of 2 theta, so I get power, that's my reduction formula. And then again, I'll break this up into 1/2, and then 1/2 the cosine. Now theta, and really what I did was actually, here's what I did. I took out the 2, so I made that 9/4. So I've got 1, and then I had to put a 1/2 here, so don't let this confuse you. First of all, take out the 2 and put this over here, and then this is what you have. But then you need to take care of this cosine, so we have to put a 1/2. We have to put a 2 here, like we've been doing, so we can use the chain rule, and I have to put a 1/2 in front. So this 2 came out, so this is what I had. So now I've got 1, but then I've got to doctor up this cosine, so I do this. Okay? And over here, same idea. I can take the 1/2 out, and I can square this out. So I've got 1 plus 2 cosine of theta plus cosine squared of theta. Then I got to do this same thing with the cosine squared. I've got to change it to 1 plus the cosine of 2 theta over 2. So you'll start to remember this power reduction formula now. And that's going to be 1/2, and that's going to be 1/2 cosine of 2 theta. Then again, I've got to put the 2's over here. Oops. Let me see it. Show you this. Get this set up here so you can see this. Pardon me. So I've got to do the same thing over here. It's kind of a long problem, isn't it? Okay. When you work it out analytically. Okay. So I've got 1 plus 2 cosine of theta, and this is the 1/2 that's over here, and then this is the doctoring up process to make this work with the chain rule. And then I can simplify. 1 plus 1/2 is 3/2, and I got 2 cosine of theta, 1/4 cosine of 2 theta times 2. That's the derivative, so you can use my cosine. And then over here, I did the antiderivative of this. So I took my antiderivatives at separate steps. Okay, so over here, if we take the antiderivative of this is going to be theta, and that's going to be 1/2, and the antiderivative of the cosine of 2 theta times 2 is sine of 2 theta. I'm evaluating that from 0 to pi over 3. Now over here, I'll take the antiderivative in this step. Well, actually, I just set this up. I simplified over here. Okay? Then I took the antiderivative of this in this step. So it's going to be 3/2 theta, and then 2, and the antiderivative of the cosine is the sine, and again, the antiderivative of the cosine is the sine, but I've got a 1/4 because of the 2 theta. Okay? And then over here, I kind of simplify this a little bit. I substituted in. So I'm kind of working this side is one step ahead of this one. So I've got 9/4. Now remember, there's 2 times all this, so I'll do that at the end. So the 9/4 is still out here. If I substitute, I get pi over 3, and then 1/2, and then the sine 2 times pi over 3 is 2 pi over 3, but that puts it in the second quadrant, and the sign is positive in both the first and second quadrant, so it doesn't really change anything. So still 1/2 the square root of 3 over 2. And I got the 9/4 out here, so I can do all this multiplying. So 9/4 times pi over 3 ends up being 3 pi over 4. And then this is going to be 9 over 16. And I got 2 times 2 is 4, times 4 is 16, square root of 3. So this is all over here. And let's look over here. Now we take the antiderivative of this. We evaluate it from 0 to pi over 3. And we get 3/2 of pi over 3. Okay, the 3's cancel, and I end up with pi over 2. 3 over 3 is 1, excuse me, then I have pi over 2. And then 2 times, and the sine of pi over 3 is the square root of 3 over 2. And then I got 1/4, and this again is also the square root of 3 over 2 because it's in the second quadrant. Sine's positive in both the first and second quadrant. Whew. All right. Now, okay, so this is going to be pi over 2, all this. And then I can multiply everything by 2, so I've got, that's negative pi over 4. That's going to be, these 2's cancel, but then I got a 1/2, so it's still the square root of 3 over 2. This 2 over 2 is 1, excuse me. So I got the square root of 3 over 2, and I got the square root of 3 over, and then I got 2 times 4 times 2 is 16. So don't forget we got this 1/2 here. So we've got 8 and 2 is 16. So I got all this numbers over here, and I got these guys over here. So can I simplify all this? Yeah. So I got, okay, 3/4 pi minus 1/4 pi is 2/4 pi, which is pi over 2. That's these things. And then I got 9 times the square root of 3. Oh, this is over 16, so that would be 8 over 16. This is pi over 2. If I multiply the top and the bottom by 8, I get 8 times the square root of 3 over 16. And then I have another square root of 3 over 16 over here. So I got 9 minus 1 is 8, but that's 8. So, or I can do it over here, 9 square root of 3 over 16 minus 8 square root of 3 over 16 minus 3 square, that's zeros. They finally zero out. So I end up with all this work and everything. I just end up with pi over 2. And that's my top sliver. But I have to double that. Remember, we have to go back and double that, so I did all that for pi. Jeepers. Okay. So you do all that work and you end up with pi for dessert. In the end, you get pi. So this was pi over 2, and this is pi over 2, so altogether we had pi. Okay? So just to do that and make it all work out and get pi, you just have to be really careful, okay? So have fun with that. Good luck.